Hello, we are presenting the problem situation with our team composed by Alejandro Gonzalez, Frida Salinas Aguila, and Camila Trejo. So for this problem situation, we have a used car dealership who is willing to predict the selling price of this Camaro car. And we have this data set that collects the sale prices of the cars and different factors of the cars. For example, the age, the mileage, the condition, and the whether the car had one owner or not. And so we want to apply linear regression to solve this problem efficiently while using software like Minitab to achieve it. So after analyzing the data set, we were able to get this linear regression model for accounting for the age and the sale price of the vehicle. And so this equation we got is the price being equal to 345,832 minus 38,144 h times h, which basically means that on average, like the price of a Camaro is going to drop by this number, 38,184, every year that it has of age. And we also got a p-value of 0, which indicates that the age is statistically significant for predicting the price. And this other r-squared value tells us that 76.11% of the variability in the sale price is a good indicator for the sample regression, but it also means that the age itself is not painting the full picture of the conditions for selling the car. Also, we use linear regression for this other part for comparing the sale price versus the mileage the car had. And we got this equation again, as you can see here. And this basically tells us that for every 1,845 kilometers driven, the car will lose approximately 1,845 pesos in value. So this model again was found to be statistically significant because the p-value we got was basically 0 and the r-squared was 73.38, which means that the mileage will explain a large portion of the price. So we made a bit of an investigation about categorical variables, and we found that they are used to classify the data points into other kinds of groups that they use some sort of quantity to represent the variable instead of just using any random like numerical value. So for our database, we basically had the condition of the car, which would be a poor or average or excellent, depending on whether the switch for the variable was turned on. And we also had the variable of whether the car had one owner or more, and that would also affect the price. So this can help adjust the precision of our regression model.
In statistics, we often use the R-squared to measure how well a regression model fits the data. It tells us the percentage of variability in the dependent variable. However, the R-squared can be misleading in multiple regression. That's because it's always increasing when we add more predictors, even if those predictors are not actually helpful. This is where the adjusted R-squared comes in. This adjust takes into account the number of predictors in the model. It penalizes the addition of variables that do not improve the model significantly, so it gives us more accurate and honest measure of model quality. And these are the two formulas for the R-squared adjustment and the R-squared. And when working with multiple predictors, it helps to avoid overfitting and gives us a better idea of whether additional variables are really useful. So for the multiple linear regression model for age and mileage, this was the regression equation where um, the the equation was 350,436 minus that number of age and that number for mileage. And this the interpretation is as a car gets older or accumulates more mileage, its price tends to decrease. For the model evaluation, we obtained that the R squared had a 81.12% of the variation in selling price, and for the adjusted R squared, it was 79.77, and this confirms a strong fit while penalizing the inclusion of extra variables. Also, the p-values were less than 0.05, which indicates that they contribute meaningfully to predicting the selling price. And we conclude that the multiple regression model, this model was superior because it has a better predictive accuracy and a stronger explanatory power.
Then we did a multiple linear regression model for all variables. And this is the equation we got. It relates all of the variables. Um, for the model evaluation, we obtained that the R squared value is 89.64, and that meaning the model explains almost 90% of the price variation. And the adjusted R square value is 87.5, uh, adjusted by the number of variables. The p-values we got was, because of the p-values, we obtained that the age is a highly significant variable. The condition excellent is also significant, and the mileage, the condition average, and the one owner variable are not significant because their p-values are higher than 0.05. And we also got that this model is superior than the ones we did before because the R squared value is higher than the others. Using the best subset option in Minitab, we also found that the best model that we could possibly get is the one that relates only four variables: age, mileage, and the condition, both the condition variables. The adjusted is R squared value we got is 87.7, which is very high. It's the highest we got. And the predicted R squared is 84, meaning it has a good capability of new data prediction. Also, the standard error was one of the lowest, and the Malo CP is 4.7. That's very close to the number of variables, being 4. And well, for this model, the only variable that we didn't include was the one owner one because it's not significant for the price. Well, that was all. Thank you very much.